convex mirror. See, concave mirror. See, this is principal axis and this is concave mirror where convex surface is painted, like this is center of curvature and this is focus. Okay, and now if I incident the light rays parallel to the principal axis, those will be reflected and passing through focus. Passing through focus. These two will directly meet at a point. These two reflected rays directly met at a point. This is known to be convergence. Convergence. So that is why concave mirrors are known to be converging mirrors. These are known to be converging mirrors. But when it comes to the convex mirror, see, this is principal axis and I have taken a convex surface in which the concave surface is painted. Okay, this is pole and this is center of curvature and this is focus. If I incident a light ray parallel to this principal axis, what happens? That will be diverged like this. That will be diverged like this. But when you extend this reflected ray, that appears to meet at focus. It is directly meeting the focus. Here it is appearing to meet the focus. That is why this phenomenon is known to be divergence. And the concave mirror is known to be diverging mirrors. Diverging mirror. So concave converging, convex diverging. Using concave mirrors we can get real images and also virtual images. Using concave mirror we can get real images or virtual images. Using convex mirror we will get only virtual images. In the examination it may be given that the mirror which forms only virtual images, that is convex mirror. The image which can form both real and virtual images, that is concave mirror. The converging mirror, concave mirror. Diverging mirror, that is convex mirror. And by using concave mirror, we get the images of highly diminished, that is in the small, equal size and magnified. We can get three kinds of images. Those may be diminished, small size. Those may be of same size. And those may be magnified, which are enlarged by using concave mirror. By using convex mirror, we will get only diminished images. Only diminished images. Okay. So these are the differences between convex and concave surfaces. Simply to understand, concave mirrors are converging mirrors in which the concave surface is the reflecting surface where it forms real and virtual images, and it can form the images of same size, small size and enlarged images. And coming to the convex mirror, diverging mirrors, and where the convex surface is the reflecting surface and it can form virtual images, that also diminished images. Okay, now let's come with the rules for the formation of images. The rules for the formation of images. whether it is convex or concave. Coming to the first, concave, converging, where the convex surface is painted. This is pole, this is center of curvature, this is focus. If you keep the image either at infinity or beyond the center of curvature, or on the surface center of curvature, or in between center of curvature and focus, or on focus. So the object, wherever you keep from infinity to focus, the images whatever are formed, real and inverted. The image whatever is formed when the object is kept in between the infinity to focus, that is real and inverted. If you keep the object in between the focus and pole, here the images are virtual and erected. This is the major rule to be understood. Okay. Now let's come to have the formation of images. Now you see here, as I told you before, if the ray is parallel to the principal axis, the reflected ray passing through focus. Here, if the ray is parallel, that appear to passes through focus. And this is concave surface, concave mirror. Here, the object is at infinity. The very first one is that object is at infinity. Then the image is formed at focus. This is diminished small size image and real and inverted. And this is real and inverted. Okay. The second one, if you observe, if the object is beyond the center of curvature, then the image is formed in between center of curvature and focus. Here, in these two cases, when the object is at infinity or when the object is in between center of curvature and focus, the image whatever is formed is diminished image. That is nothing but small image, and it's real and inverted images. Coming to the third one. Now the image is on center of curvature. The object also kept on center of curvature. So if the object is kept on center of curvature, image also, this is object and this is image, both are on center of curvature only and both are of same size. Now if the object is kept between center of curvature and focus, then the image will be beyond the center of curvature. This is object and this is image. It is kept in between center of curvature and focus, and the image is found beyond the center of curvature. Here the image is magnified. Next one, if the object is kept at focus, image will be at infinity. And if the object is kept in between focus and pole, the image will be formed on the other side of the mirror, and this is also virtual and erected. This is virtual and erect, and this is also enlarged image, that is magnified image. So this is the formation. Simply to understand, if the object is at infinity, then image will be at focus. If object is at focus, image will be at infinity. It's vice versa. You can easily remind. If the object is at infinity, image will be at focus. If the object is at focus, image will be at infinity, vice versa. And if the object is beyond center of curvature, image will be in between center of curvature and focus. And if object is in between center of curvature and focus, image will be beyond the center of curvature. This is also vice versa. And third one, if object is at center of curvature, image is also of center of curvature. And if the object is kept in between focus and pole, the image forms on the other side of the mirror, which is virtual, erect and magnified. Now you may get bits or questions from this, that the which mirror can form magnified virtual image, that is concave mirror. Concave mirror only can form magnified virtual images. At what position the object and image are both are of same sizes? When the object is kept at center of curvature, the object size and image size both are same. Okay, and where the image will be formed if the object is kept on focus using concave mirror, that image will be at infinity. Image will be at infinity. So you can understand the position of images and nature of images and size of images. It's very clear. I would like to tell you once more that one should understand this very clearly, where you get the bits from it. See, object position and image position. Nature and size. Okay, very first one, at infinity, then it forms at focus. It's real and point size image. Point size image. Second one, if object is kept beyond center of curvature, forms in between center of curvature and focus, the nature is real and inverted, and the image is diminished, means small size. And if object is on center of curvature, image is also on center of curvature. This is real image and inverted image. This is same size, equal size. Both object and images are of same size. This is in between center of curvature and focus. That image will be formed beyond the center of curvature. So this is real and inverted. This is magnified. And the next one is that if the object is on focus, image will be at infinity. At infinity, we won't try to discuss about nature and size because it forms at infinity. and if it is in between focus and pole, forms on other side of the mirror, other side of the mirror. It's virtual and erected. Then it is also a magnified image, enlarged image. Only concave mirrors can form a virtual enlarged image. Okay, now let's come to have the image formation using convex mirror. As all of you know that convex mirror is a diverging mirror where the image is virtual and erect, that always forms in between pole and focus wherever you keep the object. From infinity to the mirror, the image is always formed in between pole and focus. This is virtual and erect and small images, diminished images. Using convex mirror, only small virtual images are formed. That is why I repeated, I stressed the bit for concave mirror. Only concave mirror can form the enlarged virtual images. Refraction phenomena. Okay, now let's come to have the mirror formula. See, mirror formula is nothing but the relation between object distance and image distance and focal length. Before to understand this, let us go with the sign conventions. Sign conventions. See, let us take whether it is convex or concave, whatever it is. This is pole and this is center of curvature. This is focus. If I have kept an object here, a light ray passes from the object and will be reflected and here the image is formed. This is object and this is image. We need to go with sign convention, which is known to be Cartesian sign convention. So this is the direction of light. This is the direction of light. See, if you are measuring along the direction of light, then all the measures are to be taken positive. All symbols that you have to take as positive. Or if you are measuring against to the direction of light, that you have to take negative. That in the sense, all distance are measured from pole. Pole to center of curvature is known to be radius of curvature. Pole to focus is known to be focal length. And pole to object is known to be object distance, and pole to image is known to be image distance. Here U is object distance, V is image distance. And you know that F is focal length and R is radius of curvature. See, this is the direction of light. You are measuring from pole, object, we are moving against to this, so that object distance always negative. Object distance is to be taken always negative. For concave surface, the image is also negative, because this is also against to the direction of light. See here, we are measuring in this direction and light is moving in this. Both are opposite? No, that is why. Even focal length is also negative, because this is also measuring in the opposite direction. And radius of curvature is also negative. For concave surface, the U is negative, V is negative, F is negative, R is negative. U has to be taken negative, V has to be taken negative, and F is to be taken negative, and R is to be taken negative. And even when you are measuring towards up, that should be taken positive. If you are measuring towards down, that should be taken as negative. So that height of object is positive and height of image is negative. Height of image is negative. For a concave mirror, object distance, height of image, and image distance, focal length, and radius of curvature, all are to be taken negative. Only you have to take height of object positive. Okay. Now, if you take the convex mirror, see, if you take the convex mirror, this is convex, this is center of curvature, focus, and this is object. Here image, this is pole, this is the direction of light. For convex mirror, U is to be taken negative, because both are against. Next, V image distance, F focal length, and R, all these will be taken positive. Image distance, focal length, and radius of curvature will be taken as positive. Even height of object and height of image, both will be taken as positive. Both will be taken as positive. This is for convex mirror and this is for concave mirror. Okay. Now let's go with mirror formula. Mirror formula, that is the relation between object distance and image distance and focal length. The mirror formula is 1 by F is equals to 1 by V plus 1 by U. This is the mirror formula. 1 by F is equals to 1 by V plus 1 by U. Sometimes the problems may be given on that for a concave mirror, if object is kept at 20 centimeters, if the length of focal length 10 centimeters, what would be the image distance? That you might be asked. That you have to find out the image distance using this formula. 1 by F is equals to 1 by V plus 1 by U, as it is said to be concave mirror. U, V, F all are negative. U, V, F all are negative. Thereby you have to take U is minus 20, V is to be taken, we don't know of course, and F is to be taken minus 10. apply 1 by f is equals to 1 by v plus 1 by u. 1 by minus 10 is equals to 1 by v plus 1 by minus 20. Then 1 by v is equals to, this is 1 by 20 plus 1 by minus 10. That is nothing but 1 by 20 minus 1 by 10. LCM is 20. 20 ones are 1 ones are 1 minus 2 is equal to minus 1 by 20. 1 by v equal to minus 1 by 20. V is equal to minus 20 centimeters. That in the sense u is at minus 20 centimeters, even the image is also at minus 20 centimeters. That in the sense both are formed on the same position. That means at center of curvature. At center of curvature. This is about the reflection phenomena. This is of the reflection phenomena. Okay. Now let's go with another kind of important phenomenon, that is refraction phenomena. See, it's a common thing and most familiar thing that when you take a glass of water, when you take water half of its volume, when you keep a pencil, that pencil appears to be broken or bent. Broken or bent. So this is the phenomena. This is the phenomena where we can understand that the pencil appears to be bent, but it was not really bent. But when you trace out the reason, for this occurrence, here, see, this is when you have taken two media. When you have taken two media, that in the sense, this is one medium. For example, if you consider two mediums, see, this is medium 1 and this is medium 2. Okay, then when you incident a light ray on the interface, this is known to be interface of two media. Interface of two media. Okay, then it means the interface of two media at this point. When you draw a perpendicular line through that point, this is known to be normal. This is known to be normal. And this ray will bend and travel. The reason for bending is that changing the speed. Change in speed of light as it is entering from one medium to another medium. So that is why, due to change in speed of light that appears, that bends and travels, this phenomenon is known to be refraction of light. This is known to be refraction of light. So when the light ray incidents on the interface of two media, its speed changes and it bends and travels. This is known to be refraction of light. This ray is known to be incident ray. This is known to be incident ray, and this is known to be refracted ray. Okay, and this is known to be point of incidence, and this is normal. And the angle whatever is subtended by the incident ray with normal, that is angle of incidence. Angle of incidence, and whatever the angle subtended by the refracted ray with the normal, this is known to be angle of refraction. Angle of refraction. For example, if there is no other medium, only one medium exists, what happens? The light would have gone like this. But it was refracted due to the presence of other medium. So that this angle is known to be angle of deviation. This is known to be angle of deviation. So you can understand that incident ray is equals to the angle of incidence is equal to angle of deviation plus angle of refraction. Angle of incidence is equals to angle of deviation plus angle of refraction. So this is the pure phenomenon of refraction. See, here two medium, one is air and another is glass. One is air and another is glass. The light, whatever is incident, this is incident ray, and it meet the interface of two media and the speed changes and thereby it refracts. This is refracted ray. And here the two mediums whatever are there, here this is medium 1 and medium 2. If the speed of light is more in medium 1, then that medium is known to be rarer medium. See, rarer medium in the sense in which the speed of light is more. If the speed of light is less in medium 2, this is known to be denser medium. Rarer medium is a medium in which the speed of light is more, and denser medium in which the speed of light is low. Here, if the light ray is passing from denser to rarer, then this refracted ray bends away from normal. Under this condition, angle R is greater than angle I. Angle of refraction is more than that of angle of incidence. And here, when the light ray is traveling from rarer to denser, then it moves towards normal, where angle of incidence is greater than angle of refraction. So these are the two cases one must understand very clearly. The refracted ray moves away from normal when the light ray is passing from denser to rarer. And that refracted ray moves towards normal when it moves from rarer to denser. And this rarer denser, where you can understand by the speed of light, in the medium. Okay. Now the speed of light in vacuum. See, speed of light in vacuum, that is 3 into 10 to the power of 8 meters per second. And speed of light in air, it is also approximately 3 into 10 to the power of 8 meters per second, nearly. Speed of light in glass, 2 into 10 to the power of 8 meters per second. Speed of light in water, that is 2.25 into 10 to the power of 8 meters per second. So here, if I have taken two phenomenons, this is air and this is glass. Yeah, the speed of light in air is more. Air is said to be rarer medium and glass is said to be denser medium. Or if I have taken the two mediums, one is air and another is water, as the speed of light is more in air, air is called rarer medium and water is called denser medium. Or if I consider the two media, one is water and another is glass. Now the speed of light is more in water. Here water is considered to be rarer and glass is considered to be denser. So this rarer denser medium will be considered with the knowledge of the speed of lights in that particular medium. Here the refraction has taken place. Refraction is nothing but bending of light. That in the sense, when the light is passing from one medium to another medium, that medium allowed the light to bend and travels, to get refracted and travels, so that the medium should have a characteristic property. That characteristic property we are calling it as refractive index. Refractive index. Generally, refractive indexes are two types: absolute refractive index or relative refractive index. Absolute refractive index or relative refractive index. That in the sense, the absolute refractive index, the formula for absolute refractive index can be denoted by n or mu, that is equals to speed of light in vacuum by speed of light in medium. So formula is C by V. Formula is C by V. For example, refractive index of air. Formula C by V. C means 3 into 10 to the power of 8. This is refractive index. Is nothing but speed of light in vacuum 3 into 10 to the power of 8. And in air is also, this is also approximately 3 into 10 to the power of 8, that is equal to 1. So the refractive index of air is 1. Value is 1. And refractive index of water. Formula C by V. C means 3 into 10 to the power of 8 by water 2.25 into 10 to the power of 8. So this is 300 by 225. That is 25 12s are, 25 9s are, whereas 3 4s are, 3 3s are 1.33. Refractive index of water is 1.33. And refractive index of glass. Formula C by V. C means 3 into 10 to the power of 8. And this is 2 into 10 to the power of 8. This equals to 1.5 into 10 to the power of, 1.5 into, these two are cancelled, 1.5 is the refractive index. So this is the way we can find out the refractive indices of different media. Understand? And coming to this refractive indices. Coming to the refractive indices. As I told you that n equal to C by V or mu equal to C by V. If the refraction is taken place between two media, this is medium 1 and this is medium 2. It will have one refractive index, that is mu 1, and this will have another refractive index, that is mu 2. The light ray starts from first medium and refracts in second medium. Now the refractive index of second medium with respect to first medium. If I have written mu 21 is nothing but refractive index of second medium with respect to first medium. if I have written mu1 2, which you can understand that refractive index of first medium with respect to second medium. The refractive index of second medium with respect to first medium can be written as mu2 by mu1. Mu2 by mu1. This is relative refractive index, means we are comparing the refractive index of one medium with respect to the other medium. So now let's come to know about this refractive index, that is especially relative refractive index. See, as you have written that refractive index of second medium is equals to refractive index of second medium by refractive index of first medium. For refractive index of second medium, you can write that C by V2 formula. Now only we learnt. And this is C by V1. C1 ja cancel. So it can be written as V1 by V2. As you know that velocity is nothing but the product of frequency and wavelength. So you can write it as V1 equal to nu into lambda 1, V2 equal to nu into lambda 2. Nu cancel. So the total relation you can go with that mu2 by mu1 is equals to V1 by V2 is equals to lambda 1 by lambda 2. This is the relation between refractive indexes and velocity of lights and the wavelength. And during refraction, one thing will not be changed, that in the sense that remains unchanged, that is nothing but frequency of light. During refraction, frequency never changes. So this is of refraction phenomena. See, refraction maybe takes place on plane surfaces, that what you have learnt in the case of reflection, it may be taken place on curved surfaces. See, on plane surfaces, let us take a plane surface. Here this is medium 1, known to be rarer, and this is denser medium. Okay. Denser medium. Now the light ray is incidented from denser to rarer with some angle of incidence I1. Then it bent away from normal. Now this time, if you increase the angle of incidence more, then instead of refracting, you can observe that it grazed on this interface. That in the sense, angle of refraction is 90 degrees. Then the angle of incidence for which the angle of refraction is 90 degrees, this is known to be critical angle. Critical angle is nothing but it is an angle of incidence for which the angle of refraction is 90 degrees. Okay. Now you incidented the light ray where the angle of incidence is more than the critical angle condition. Then instead of refraction, this refracted ray bounced back into the same medium. This phenomenon is known to be total internal reflection. Total internal reflection. Say, for total internal reflection, the conditions are two. That in the sense, the light is to be traveled from denser medium to rarer medium, denser medium to rarer medium, and the angle of incidence should be greater than to angle of critical angle. Then the refracted ray, instead of refracting, that will be bounced back into the same medium. Then what is the importance of this total internal reflection? See, sometimes we use it to see that some water is deposited on the road as we are traveling on a fine sunny day. But basically when we go there, water will not be found. So it's just an optical illusion. That optical illusion is known to be mirage. Mirages are formed due to total internal reflection. Sometimes you can see the image of the tree or a building, whatever is there, at a far distances as you are moving on a fair sunny day. For example, see, we are moving on a fine sunny day. The sun, who emits the light and heat. So over the earth's surface the heat is more. So thereby the density is less. As you are moving up, the density increases. Okay, and here a person is watching, and here a tree is there. So the light falls on the tree and that will be reflected and goes where angle of incidence will be more than critical angle, that moves like this, and that appears that the tree will form an image here. But when you come here, really you can't see the image of tree. So this is a pure mirage. Mirages are formed due to total internal reflection. Even the brilliance of diamond, is also